1.60. This is a good problem. In the arrangement shown in the figure, the masses m0, m1 and m2 of bodies are equal. The masses of the pulley and the threads are negligible and there is no friction in the pulley. Find the acceleration W with which the body m0 comes down and the tension of the thread binding together the bodies m1 and m2. If the coefficient of friction between these bodies and the horizontal surface is equal to K. Consider possible cases. Okay, let's draw the figure first. We have a body M1 and then there's another one M2. They're attached by a string and this string goes over a massless pulley and there is another body which is hanging here. This is M0, this is M1, this is M2. So it says that M0 comes down with an acceleration W and we need to find the tension in this thread. Let's call that T. Okay, and then the coefficient of friction here is K. And so we'll have to find W, right? Most students approach this problem, they start to immediately draw the free body diagram of M0, M1 and M2 and things like that. But let's consider the concept of a system. Now if you consider M0, this string, M1, this string and this M2 as one system, okay? So then we can apply effectively Newton's laws. Now if we consider that as one system, what is the force, external forces that are acting on the system? This tension in this string, is that an internal force or external force? That's an internal force because this tension will cancel. I mean, there is tension here, there is tension here, so it cancels out. There is tension here, there is tension here, it all cancels out. So that is not an internal force. In the y direction, we also have m1g in the downward direction and the normal reaction, that also cancels out. Same thing with this. But there are two other things acting, that is the friction force here. Those are external forces. This friction force is Kn or Kn1 and this friction force is Kn2. The not if this one was m1g, the normal reaction is n1. This one was m2g, the normal reaction would be n2. Okay. The external forces that are acting on the system are m0z, m1g, normal reaction, m2g, normal reaction, and these two frictional forces. The tension force is not external force on the three body and the string system. Okay. Now, if we, so these m1g and n1 cancel out, m2g and n2 cancel out. That's the reason these masses m1 and m2 don't fly up. What is then remaining is along this path we have m0g minus kn1 minus kn2, and that is responsible for the acceleration of the entire system, not just m0z. So this is m0 plus m1 plus m2 w. Okay. Let's go over this concept one more time. My system that I have chosen is comprised of M0, M1, M2 and the strings. On this system, what are my external forces? The external forces are M0G, M1G, M2G, the normal reactions N1, N2 and the friction forces Kn1, Kn2. These are all the external forces in all directions. Now M1G and N1 cancel out, M2G and N2 cancel out. So these are only three external forces that are acting on my system. That is important. So now if you equate, because M0G is what this entire system is getting pulled in the downward direction, and Kn1 and Kn2 are in the opposite direction, that is responsible for the acceleration W of the system. The system comprises of all these three masses. Okay, so that gives you this. Now then from this it is pretty simple. W is M0G minus K, N1 is M1G minus K M2G divided by M0 plus M1 plus M2. Okay, we can take a G out, M0 minus K M1 plus M2 divided by M0 plus M1 plus M2G. Okay, so understand what system you are choosing. Okay, now the next question is to find this tension. Now tension is an internal force in this system, so I have to change my system. Now I am choosing my system as what? As M2 and the string attaching M1 and M2. Now what's the free body diagram of that? So we have M2G in the downward direction, there is a normal reaction N2, there is Kn2 friction, and then there is T, the tension on this string. Now this tension is an external force that is acting on M2. See, once you choose your system, you then find out what are all the external forces acting on the system. So these are all the external forces acting on the system. Now because M2 is not flying up, and the normal reaction and M2G must be cancelling out. Okay. However, this system also is accelerating in this direction in W, because this is continuous. There is no slack in the strings in either this string or that string, right? So the entire system is accelerating with acceleration W. So then it follows, we can write T, the tension, minus Kn2 is responsible for M2W force. Okay. Now from this we can find out T as M2W plus Kn2. Now we can substitute W is M2G, M0 minus K, M1 minus K, M2 divided by M0 plus M1 plus M2, right, plus K, N2 is what? M2G. Okay. So in fact, M2G we can take out, and let's write the denominator M0 plus. That's the answer.